All right, welcome everybody. This is day one of 5.09. Today's Wednesday. Yeah, Wednesday, 4/7. All right, component form of a vector. So we're gonna write a vector in component form. Being recorded. All right, vectors. Where's my pointer at? Here we go. All right, so let me move the glasses on. Okay, so a vector is a measure of something in terms of both direction and magnitude. Now that's important. You're not going to have any questions on your test about the definition, but you need to understand that vectors um, have direction and magnitude. So similar to array you learned in geometry, you have a starting point and then it has a direction, right? And just an arrow that goes on forever. Vectors, it's similar. You have a starting point, and with vectors, you have an ending point. But on the graph, it's still shown as you would graph array. You just have one arrow on one end of the line. So vectors show direction and magnitude. Now, magnitude is basically distance. That's what magnitude is. All right, so common vectors you're probably familiar with already is velocity. I feel like we did this already, talking about velocity. All right, so speed is the magnitude, and the displacement is the magnitude. Distance is the magnitude. I think we talked about velocity versus speed, maybe last unit. So there is a difference. And if you take physics, you will learn the difference between velocity and speed. There's a difference. I won't get into it though. But anyway, all right. So for our purposes, all vectors have an initial point and a terminal point. So that's important also. I'll be talking about initial points and terminal points towards the end of this lesson, especially when dealing with something we're going to learn about called component vectors or component form, which we'll get there soon. All right, so for notation, an arrow points in the direction from the initial point to the terminal point. So it's pretty easy. When you have the vector AB, A is the initial point, B is the terminal point. This looks very similar, if not identical, to what you saw in geometry when dealing with rays. But now we're talking about vectors. So it looks the same, but it's different. All right, any questions about these definitions before we go on? Emily, are you confused? What words are we confused about? You don't know what you're confused on? You're confused, but you're not sure on what. You can't really be specific. Okay. So maybe if we start seeing some examples, it might kind of maybe the pieces might fall into place, right? Okay. Hopefully. I hope so too. My computer wants to restart. Hey, if I get disconnected, it's because my computer restarted without me saying yes. I've already said no twice in the last 5 minutes. Yeah, hopefully it doesn't restart my computer. Anyway, component form of a vector. All right, when writing a vector in component form, this is important. The initial point needs to be at the origin. Now remember, on a graph, an XY Cartesian coordinate plane, the origin is the very center. That's the origin, if you've forgotten. So component form. Again, to be in component form, the initial point must be at the origin. If it's not at the origin, it's not in component form. All right, the terminal point is a point where the vector ends with an arrow drawn from the initial to the terminal. When writing the component form, you simply need to include, what does that say? The coordinates of the terminal point as Now look at these symbols. This is not a parentheses. These are the what's the correct name? Does somebody know the correct name of these? I don't want to say less than and greater than because that's not what it is. Somebody. So yeah, I'll go with what Chloe says. Sideway V's. They're sideway V's. That's not the correct term. But yeah, these are basically sideway V's. They're like greater than, less than symbols, but that's not what it is. So yeah, they're just sharp parentheses. This shows in vector form, the component form that is. Okay, dog's in my lap. He's happy. Yeah, they're just. Is it too small on your screen? Is that why you're having trouble seeing it? It's not super sharp. I can draw them bigger. Let me. So it looks like this. Okay, let's try that again. Okay, my touchscreen's not working. Okay, hang on. It doesn't work. You unplug it, plug it back in, right? Isn't it how it's supposed to work? Hang on. It's not working. What's going on? Hello, screen. That's aggravating. Okay, it's working now. I tried a different USB slot and now it's working. Okay, we're good. All right, you got your X and you have your Y. Yeah, they're just sharp parentheses. Sideway V's. So Google says sharp parentheses is an angle bracket. Okay. So angle brackets. All right, we'll go with that. Google's never wrong, right? All right, so drawing vectors in 3D form. When you're given a vector, you have X, Y, and your Z axis. Now, you should have learned this back in geometry, at least how to plot 3D points. These are the sharp angle brackets, so it's a vector in component form. Now, pay attention to the X, Y, and Z. Your X is the one that's actually, you can imagine it's coming out of the wall. Towards you is positive. Forward towards the wall that's in front of you would be negative. So that is your x-axis. Your y-axis is the one that's left and right, positive being right, negative being left. And then your z-axis is up and down. So going up is positive, going down is negative. All right, so plotting the point the vector 2, 4, 3, you just, in the x direction, you're going to go 2 units positive. So we have 1 and 2. And then the y is 4 units. So we go to the right 4. 1, 2, 3, 4. And then the z is 3. So you go up 3. 1, 2, and 3. And that's why we end up there. So then from the origin is where you start. And you draw a line with an arrow at the end, stopping at that point. And then they drew this box to kind of help us visualize three dimensions on a 2D surface. So good news is you don't have to do this on your test. In fact, on your test, you don't have anything in 3D that you have to worry about. But I just wanted to show it. So let's look at 2D ones. We'll do the first one together. So we want to draw these vectors on the coordinate plane. So 1 comma 5, you treat them like regular coordinates. We're going to do a point at 1, 5. So over 1, up 5. I'm going to do a bigger. Oops. All right, over 1, up 5. So over 1, up 5. 1, 2, 3, 4, 5. So that puts us there. And then we draw a line with an arrow. I cannot find the line tool for the life of me. Oh, found it. All right, I'll do, I think that's green. So a line, and then we have to put an arrow at the end of it. And then that's how you would graph it. That's it. I only know it's green because you told me last time. And I believed you. Nothing tricky. Volunteer to do the next one for us. All right, Emily, you can do the next one. How about the third one? Who wants to do that one? Emily, and use red for that one. Who wants to do the third one? All right, Sarah, do the third one and use blue, please. How do I do a straight line? So if you click on next to your text tool, there should be like a pull down to select a shape. It might be set on like the square by default, but you can click that and choose the line tool. Yep. They all look good. All look good. Any questions before we go on? Probably wondering when will this actually get hard because you know it's coming, right? All right. A vector in 3D form. Does anybody want to try this for funsies? You want to give this one a shot? You remain hopeful. It doesn't get much harder than this. someone want to give this a whirl? Like Jacob, you're still here, I hope. You know, if all of you in chat volunteer to do a problem, I'll have 100% of people participating, and that rarely happens. Granted, there's only 4 of you here, but still, 100%. Jacob is ghosting me again. All right, Emily, go for it. Oh, there he is. All right, Emily, go for it. Nothing's happening on my screen. Oh, there it is. So don't forget, x is negative. So going backwards is a negative direction. So you should have counted 2 back this way. That might be the point where you end up at. Let's take a look. Back to. Nope. I'm going to say that is no good. Emily, if you want to use your arrow and kind of take me through your path of where you went, going from X, Y to Z.
Yeah, so I have literally no idea why I was doing this, but I went. Hang on, let me grab the arrow. So I went from the origin. I went left 2 to -2, and then I went down.
Look. But look, this is the Y-axis.
Oh.
So in 3D, it's totally like not the same.
Oh. Okay, that's weird as heck.
So yeah, so your X-axis is the one that's
Fine.
coming out of the wall, right?
Okay,
Yeah.
okay. Let me undo it and try again.
Okay. When you all took geometry, if you remember, did they present the 3D plane like this, or did they tell you the one coming out of the wall is the like Z-axis? Did they?
Yeah, same, Chloe. I didn't learn about this.
I think
I've never heard of
learn
this
about
before
3D
now.
vectors in geometry, but you should have learned about plotting points in 3D space. Like on a 3D plane, you should have learned that either Algebra 1 or geometry.
For me, they only mentioned it for like future reference that we'll need to understand what it is, but we never worked with any problems that included that.
Okay.
It was only, like Chloe said, 2D vectors.
Okay.
Is that a little bit closer?
All right. So use your pointer and kind of take me through this pathing that you did.
Okay, so I used the x-axis and I went down 2 from here, so I went to here.
Wait, but it's -2.
Wait, so wouldn't you go down 2 then?
So it's in 3D space. So you gotta visualize this line right here is coming out of the wall towards you. And this dotted line is going back, well, forward, going, I guess, backwards, right? So this is the front and this is the back.
Wow, I'm having a stroke right now.
It's hard to visualize 3D on a 2D page, right? Let me go back
Yeah.
to this one here. So there's actually a 3D box, right? So this is the top of the box. This surface is the front of the box. This is the side of the box. And then everything else we can't see because that's behind the box. Can you visualize that 3D box?
Kind of.
Kinda. Does it hurt your brain?
Very much so.
Okay, I'm gonna turn it into a bus. Maybe if it's a bus, it might be easier to look at. Just for fun, let's put wheels on this thing. So here's the front wheel. Here's the back wheel. Here's my windshield to this bus. Here's the grill. And then here's windows going down the, I don't know. Does that help?
But the way I thought you said that you're going to turn into a bus.
I'm not turning into a bus. My picture's turning into a bus. To hopefully help visualize this 3D object.
I died.
Is it working or no? Is it just not?
Yes, I can visualize it. I just don't understand how it exists, but it's fine. I can visualize it.
So you can see this is the front of the bus, right?
Yeah.
So that's why coming from the origin and going this way goes towards the front, so it's positive. And then if we were to travel this direction, it goes towards the back of the bus, so that's negative.
So it's literally negative. It's literally backwards. That's weird.
Yeah, so not everyone is like, I guess, spatially inclined, right? Who can visualize 3D objects in their head and like flip them around whatever in their head. It sounds like you might be having trouble with that, and that's okay. Not everyone can do that.
Yeah.
So 3D on a 2D plane or on a 2D surface is hard for a lot of people. So don't feel bad. But yeah, so this is the x-axis, and this is towards the front. This is towards the back. And then for the y-axis, so we're so used to having y being up and down, but on this, your y-axis is actually now the horizontal line. So going to the right is positive, and going to the left is negative. And now what we're so used to seeing the x-axis is now the z-axis. So going up and down is the z-axis. Does anybody here use like Blender or any other 3D modeling software? There's only 4 of you, so the odds of one of you doing it is probably pretty low.
I actually did. I took 3D modeling last year.
Did you use Blender?
Yeah, we use Blender.
Okay, so you should be used to having a 3D plane because you get to flip stuff around and, well, model stuff, right?
It's just easier to see when you actually have it 3D and you can turn around and look.
When you can actually like grab it and like flip it around and you can see it turn versus trying to think about it, right? Okay, fair enough.
And you can see that it's 3D, like the object. So.
Okay, fair enough.
Yeah.
Now, do you remember in Blender if their axis if they labeled them the same, this being y, this being z, and this being x?
I do not remember.
Okay. I'm just curious. I've used it before. I just haven't used it in a long time. Anyway, so that software would be like a good example of why you would want to, well, know how to like plot points and to, basically create your 3D models. But anyway, let's go back to this problem here. Do you want to try this again, Emily? Now that we talked about it.
I'll try one more time, but if I get it wrong, I'm not trying again.
All right, use your arrow. So use your arrow and just show me where we go from X, Y,
okay,
Z.
So you would go from the origin to here.
Good. That's right.
-2, and then you would go left 4. So 1, 2, 3, 4.
Perfect.
So here,
okay.
and then up 2. So here.
Perfect. So I'll keep my arrow here. So I want you to draw your line from the origin to that point.
That's a wonky line, but it's fine.
Yeah, good enough. Good enough. And I won't have you try to draw the 3D box. That is challenging by itself. But yeah, that is perfect. That's what you would have if you had to do it on your quiz or your test, but you won't have any of these on your test. It's just good to know. So
Sarah, I went from the origin here and then go like back to, because it's like backwards. So this is where I went with the -2.
Oh, okay, yeah. I completely know.
Okay, cool.
And then I went ahead and did a 3D box to help you try to see it in 3D. But you don't have to do that.
Okay, I think I like mostly get it.
As long as you can follow the pathing, like we went through, Emily, of
Yeah,
knowing
I just honestly have no idea what the X axis did, because that's so weird.
Yeah, and I wish I could like grab this axis and kind of rotate it to show how it's actually, this line is actually, so imagine putting a pencil on your screen and having it come straight out of your screen. That is the X axis, and coming towards you is positive, and going through your screen to the other side is going negative. So looking at this at kind of just quick glance and not knowing this is 3-dimensional, seeing how this is negative and this is negative, you would think that this is -2, but it's not, because it's 3-dimensional.
So would the x-axis just be depth? Like, would that be?
Yeah. I would say x-axis is depth. We're talking about vectors. Yes, depth. And z would be height, and then y would be width. Yes, that would be a fair assumption to make.
Weird, but
super weird. All right, let's go on to more important things other than 3D vectors. Draw 3. Okay, we'll skip this part. Okay, now to the fun stuff. Component form. So you're sometimes given a vector that does not originate at the origin. When that happens, that tells us that vector is not in component form. So again, to be in component form, it has to originate at the origin. So your initial point must be at 0, 0. So we have this point. We have vector rs, where your r is at 1, -2. So there's that point, 1, -2. And your s, your terminal point, is at 3, 5, right here. So all you got to do, like this second bullet point says, is imagine you're taking this vector and you're just sliding it over so your initial point starts at the origin. So to make that happen, I would want to slide this to the left how many units? Yep, to the left 1 unit, and then I want to slide it up how many units? 2. Perfect. So that's all we're doing. We're just sliding it left 1 and up 2. In that way, in component form, it originates at the origin. But don't forget, when you slide this point left 1 and up 2, you're having to slide this point as well, left 1, up 2. So you can think about you're taking this 3, subtracting 1, you're taking this 5, and you're adding 2 to it. That's all you're doing. And there's a formula for that, which I'm going to show you not on this page, but the next page, I think. So we'll get there. All right, so 1, -2. This is from the previous page, right? It is. All right, so I'm going to redraw this. Let's see. So over 1, down 2. And then I'm going to 3, 1, 2, 2, 3, 4, 5. Okay. All right, so there is vector rs that is not in component form yet. So all we have to do is you are sliding up 2 and left 1. And it needs its hat. So in component form, I should have typed this out and I didn't. So vector rs is equal to, all right, what's that new coordinate? 2 comma something, right? 2 comma what? 2 comma 7, thank you. All right, so now vector rs is in component form. And that vector is 2 comma 7. And that's all it is. That's component form. Just know it must originate at the origin. And there's a formula for that. So when points are easy, like this, these points are easy, right? But when you have vectors that are kind of scattered everywhere and it's not as easy as just counting to like 2 or 3, it could be a matter of counting like to 10 plus, right? Either positive, negative in X and Y directions. So there's a formula for that. And this is noteworthy, so probably want to write this down. So to write a vector in component form, given the 2 coordinates, the new vector, the x coordinate is going to be your x sub 2 minus x sub 1. X sub 2 is the terminal point. X sub 1 is the initial point. And then same thing for your y. It's going to be y sub 2, which is the terminal point, minus your y sub 1 initial point. So going back to that previous example, oops. So R is the initial. and then S is your terminal point. So math-wise, we do 3 minus 1 comma 5 minus negative 2. And then that's how we get 2, 7 using the maths. Pretty simple formula. It doesn't get harder than that. Unless they're like radicals or fractions, then I guess it looks harder, right? But it's really not. It's the same formula. All right, so let's look at these. Also, make sure you take note. Remember, your initial point is the first letter that's listed. So in the vector CD, C is the initial, D is the terminal. All right, so I will give all of you, let's say 1 minute for the first one. We'll do one at a time to make sure we're doing them right. By the way, these are the last 4 examples we have, and then we're done if you're wondering. So 1 minute. All right, what'd y'all get for the first one? 6 negative 7? I think that sounds right. You know, we almost had 100% response. Thanks, Jacob. You just copy the person above you. It doesn't count now. All right, let's see if that's right. -6, -7. All right. All right, everyone try the next one. Give you 1 minute. Jacob, I'll give you 1 minute and 10 seconds. Yeah, don't feel bad if you take extra long time. I was always that kid too. Yep, Jacob smiley face, super sus, right? All right, what'd everyone get? Ooh, 9. Everyone got 9.6. That must be right. I got negative 9.6. So either all of you are wrong or I'm wrong. Is it 100% of the class wrong? That's here. There's only 4 of you here. Or am I wrong? Well, hang on a second. Let's see. Let's see if who made the mistake. All of you or me? Because me making mistakes, that doesn't sound right at all. All right, let's take a look. So vector AB, A is the initial point, B is the terminal point. So the formula says terminal point minus initial point. So terminal would be the B. So I'm pretty sure we would have -2 minus 7. What do you think? What do you think? Ooh, did I write the points backwards? Did I put B first and then A, even though I put vector AB? Did I fool all of you? I want an apology from every single one of you. You will not. Chloe's mad. I can tell. Yes. See, when speed is a factor in solving any problem, not just math, but just any situation in life, when speed's a factor, mistakes are made really easy. This being one of them. Before class started, I went through and I made sure I did these 4 correctly, because I didn't want to be the one that was wrong today. Ooh. But does it make sense why the answer is what it is? Okay, and I just happened to trick you guys, and that happens. It does make me happy that I tricked all of you and not just like 1 or 2 of you. Oh, ouch. I have a good story about prom for you guys after this lesson. Anyway, RS. Let's try that one. Let's try this one. Minute and 10 seconds. Ready, go. I like it. You were testing me. You know, when all of you wrote the wrong answer, it made me think whether or not I did it right. So well played. Well played. Oh, also, I got lucky and I got out of doing Ames proctoring next week. So I will actually be able, I'll be here if any of you need help anytime during the day. Yes, lessons are still repeating. So I won't have any live sessions next week because we're doing them this week. All right. So we got 303096. So we got you may have been looking at the wrong problem when you put your answer. 318.
Yeah, I copy pasted my answer from the last problem.
Looks like it, yeah. So our initial point S is terminal point. Remember, it's terminal minus initial. So -3 minus -6. So hopefully all of you are writing down the work. So if you notice, like in this first problem, I wrote out this work. The next problem, I wrote out the work. All of you should be writing this step down, and none of you should be jumping right into typing it in. If you're typing it in right from like your brain, that's not good. You want it to try to incorporate more senses into your work. And if you can think it and see it, to me, that's twice as good to make sure you don't make a mistake than just thinking it and typing it in, if that makes any sense. So that's what I have for my X value work. Do all of you agree with that? Emily? Yep. So yes, 3 is correct. Chloe's changing her answer. Looks like all of you are changing your answers. So I'm scrolling back up in the chat log to see who got it right the first time. And it looks like Emily would have if she didn't put the wrong answer from last problem. Right, Emily?
Yeah.
Okay.
I just realized my mic was still on. Haha.
It was.
You could hear me chewing my nails.
I no judging here. All right. So all of you are thinking it's 318 now. Now, are you all making these simple mistakes because you're trying to skip steps? Is that what's going on? Oh, you just typed it wrong? It's because all of you are hungry and tired and want to stop this lesson now. All right. So on purpose, I made the mistake because we all know that 9 minus -9, 2 negatives become what? Positive, right? So 9 plus 9 is what? 18, right? Right, exactly. So the answer is 3, 18 in those angled brackets. But on purpose, I put 0 to trick all of you, to tell me, hey, you're wrong, but you already caught your mistake. Yeah, totally did that on purpose. I'm bad just like all you. 3, 18. Yeah, that's not the right answer. So that is. Yep. Yeah, that was a typo for sure. Pre-calc class, trust no one. I'm telling you, we need to get t-shirts that has that. Pre-calc class, trust no one. It's true though. It's true. So, all right, everyone, nice job catching your mistake. 3, 18. All right, now this last one. Now I want you to be all very careful so we can all get this last one correct together. So I'm going to give you all about a minute. I'm going to check my PowerPoint to make sure that I actually did do it right and didn't mistype something on purpose. All right, if you're done with the problem, give me a green check. So I know you four are done. All right, everyone's done. So in chat, go ahead and write your final answer. Dun, dun, dun. 15-9, 15-9, 15-9. Emily. Jacob got -15, -9. Chloe 15-9. Sarah 15-9. Emily negative. Okay, so Emily and Jacob got the same answer. So we have two answers. So likely two of you are wrong, two of you are right. It's funny. This is funny because this is by far not the hardest concept we have learned all year long. This may have been one of the easier ones, right? So it's kind of funny because there is so many more things we've done in this course that is way harder than this. It's just really late. Yeah, it's late. We're tired and we're hungry. I agree. Blood sugar is low. I make lots of mistake. Your brain is powered by your glucose in your blood, and when your blood sugar is low, you can't think very good. Yikes! Yikes! All right, so those two people that probably got it wrong. Do you see your mistake? Okay, Emily says yes. All right. Jacob says yes. All right. So it is 15-9. There's my work. And we could actually show one more step. I didn't. Like maybe if you're missing these because you're just numbers are hard today. Writing 6 minus -9, maybe on the next line put 6 plus 9 as the middle step between the answer and your setup. And then you can see 6 plus 9. Oh, I know 6 plus 9. That's 15. And then same thing for this. You can two negatives make a positive. You can write -1 plus 10 and say, oh, -1 plus 10. Oh, I know that. That's 9. And that way you won't make these simple mistakes. Come on. Come on. That's my girl. All right. Any questions on this, guys? Are they? They're not still there, are they? Some people actually. How many people were actually in there?
So it was me, Sarah, Jacob, and then Michaela when I left. But I left almost immediately when you messaged me on Skype.
Nobody said,
So-
"Hey, there's a neuro session. Everyone join that."
No, because in Blackboard, chat's off unless there's a moderator.
Oh, that's so lame. All right. So I can't blame you. I was gonna say it's Emily's fault. Everyone who didn't show up to neuro, it's Emily's fault. But there's no way
Wow.
of her. Okay, there's no way of her telling them. So they should have hit refresh F5.
Hey,
Right,
I
everyone.
did tell Sarah.
Okay. Nobody messaged me on Skype, so there you go. Thanks for hanging around, and as always, I hope you learned something. See you tomorrow.
We need to hear your story.
Oh yeah. Okay.